The next thing to review is squeeze theorem. At any moment when you're trying to solve this problem, press pause before looking at the solution. So here we have a function that is not so nicely behaved. And that's because we have sine of pi over x. To solve this function, we can squeeze it between two nice functions. So to do so, observe that sine of pi over x is, no matter what's the angle, always smaller than or equal to 1 and always bigger than or equal to minus 1, which implies that the original expression is between root of x cubed plus x squared with a negative and it's bounded above, so I multiply each part of the inequality by root of x cubed plus x squared. Thereby the middle guy is squeezed between minus root of x cubed plus x squared and the positive cube root of square root of x cubed plus x squared. Now as x is going to 0, this guy goes to 0. This guy also goes to 0. So that means that the middle guy is forced nowhere else but to 0. Let's consider a few more squeeze. So suppose that what we have is limit as x goes to 0 of x to the power of 4 cosine of 2 over x. Again, exactly the same idea works. We have that cosine of 2 over x is between 1 and minus 1. That means that if I multiply by x to the 4th, I have minus x to the 4th less than or equal to x to the 4th cosine of 2 over x less than or equal to x to the 4th. Now, this goes to 0 as x goes to 0. This goes to 0 as x goes to 0, forcing the middle guy to go to 0 as well. Example number 3. Let's try to calculate limit as x goes to 0 plus of root of x times e to the power of sine of pi over x. Now what do we see here? We see that sine of pi over x is between 1 and minus 1. What does it mean? It means that e to the power of minus 1 is less than or equal to e to the power of sine pi over x, which is less than e to the power of 1. What I'm again trying to do, I'm trying to engineer the original function out of those inequalities and thereby squeeze the original function between two functions that I easily can control. Now the next step is to multiply each part of the inequality by root of x. So we have that root of x times e to the minus 1 is less than or equal to root of x e to the power of sine pi over x less than or equal to root of x times e to the power of 1. Now x approaches 0. So this is just root of 0 times e to the minus 1, which goes to 0. This also goes to 0. So forces the middle guy to go to 0. Again, we squeezed between two algebraic functions. We squeezed the middle guy between two algebraic functions. Now the fact that the answer is 0 is just coincidental. We just don't have too many nice examples to see how the squeeze theorem works. But let's just show that it's incidental by considering the following questions. Let's consider that we have a function f whose formula is not known to us, but we know that it is between -1 as its lower bound and x squared minus 2x as its upper bound for all x. So then let's try to calculate what is limit as x goes to 1 of f of x. Now again, what we can do here is we already have everything wonderfully squeezed between -1 and 1. So you see that we don't need to do much work. We just use the upper bound x squared minus 2x and the lower bound -1 and then see what happens. So as x goes to 1, -1 stays -1. Now as x goes to as x goes to 1, what we get here is 1 squared minus 2 times 1, which is also -1. So f of x is squeezed between -1 and -1, therefore the middle guy has to go to -1. That means that this limit is -1. All right, one more question for the squeeze theorem. Question number 5. Suppose that what we have is limit as x goes to infinity of x cubed sine 1 over x plus 1 divided by x to the power of 6 plus 10. So in this case, observe that x cubed sine of 1 over x plus 1 divided by x to the power of 6 plus 10. So the numerator is at the very best x cubed plus 1. And at the very worst, the numerator is minus x cubed plus 1. Now, as x goes to infinity, this guy approaches 0. This guy also approaches 0, forcing the middle guy to go to 0. One final question for the squeeze theorem. So try to calculate limit as x goes to 0 of x times cosine e to the sine 1 over x. Now again, this place we just have very few functions to play with. That's why the examples are so simple. We have that cosine of e to the sine of 1 over x is always less than or equal to cosine of e to the power of -1 and bigger than or equal to cosine of e to the power of 1. That's because of the property of cosine. The smaller the angle, the closer the angle to 0, the more cosine is like its biggest value 1. Now, if I now multiply everything here by x and push x to 0, observe this is just x multiplied by a constant. This is a constant. This here is also a constant. So this really goes to 0. This really goes to 0. And the middle guy goes to 0. Now you can see in my notes where the squeeze theorem is non-trivial. You can use the squeeze theorem to show that limit as x goes to 0 of sine of x over x is equal to 1. This would be much more work than here. Similarly, you can show using the squeeze theorem that limit as x goes to 0 of cosine x minus 1 over x is equal to 0. Also requires much more work. But it's good enough for today.